You do have to. Okay, it's the first time. Okay, so you don't want to get it. I'll tell you when you get a good point.
Okay, hey everyone. It's the moment you've all been waiting for. So time for the project presentations. If you were able to upload your presentation into GitHub, it should have been pulled into by 2 o'clock. All of those got pulled into Miteco. Now, if it's an HTML file, you won't be able to present it as uploaded slides. You'll just have to share it from your laptop like you normally would. If it's a PowerPoint, I'm actually not sure how that'll work. If it's a PDF, then you should be able to drive it from within Miteco as I am here. But in any case, we should be able to share all the presentations using some of the functionality we have. And we'll work with you to get you set up. But the idea is make sure you're logged into Miteco if you're going to be presenting. And when you present, you'll just be sharing from basically your laptop and driving from your laptop. So bring it up, you can stick it here. Keep your camera off, keep your audio off. This will be your microphone, there's your camera. So you don't need to use those from your laptop. Hopefully that all makes sense. We're gonna learn as we go along and have some fun with it. We do have, I believe, plenty of time for all the presentations. We still ask that you keep them to no more than 5 minutes, just so that we were able to get through them. Just have a few slides. We covered the note well yesterday. That still applies. That's where we're at. I was just telling you about the 5 minutes. And I think we covered that too. And here's something, if you're just logging into the Miteco and you're trying to find out how to do it, if you go to the agenda, you should see a little camera icon there. If you click on the camera icon, that'll bring you into the Miteco session. Once you're in Miteco, there's 2 different ways to share. The one is to share using preloaded slides. And that functionality is really slick. And if you happen to have a PDF that you uploaded into GitHub before, you'll be able to make use of that. And if not, you'll have to just request a share screen. The way to do that is using these 2 icons. The one on the left is to share preloaded slides. The one on the right is to share your screen. So depending on which functionality you need to use to share your presentation, you can choose one or the other. In some cases, the preloaded slides will work. In all cases, if you're just more comfortable sharing from your screen, you can always do that. But again, just request to share when it's your turn to present. Come up with your laptop and you'll present from here. Any questions? Okay, great. So now all we need to do is work through the presentation. So what I'm going to do, and I don't quite know how to prepare for this otherwise, is I'm just going to start at the top and work through. So the first one I see is dance. Is whoever is from here. It looks like it could be a remote presentation. Over here. Okay, perfect. Great. So you can just share that as preloaded slides if you want. Do you have it in your laptop already? So let's try this. I can share from here. And now I might need to drive the slides for you. I don't know, but come on up. We'll see how it works. Okay. And let's make this big. Okay, give that a try. Here, let me take this off. And you can just advance. Does that work?
That works. So, hello everyone. I'm going to quickly present to you the work we've done on dance. So, oh, sorry. Oh, that's better. Okay, so I'm going to present the work we've done on dance. So we've implemented the two drafts that are here. So the first one is a TLS extension to add a Dane client ID in TLS. And the second one is to do the Dane client authentication. So for the Dane client authentication, we based on work on the Dane, the TLSA authentication library that has been written by Schumann. So this is a Go library. And we've set up a testing environment to test client and server mutual authentication in TLS using DANS. So we've added the Dane client ID extension in TLS 1.2 and 1.3. And we also implemented the fallback using the subject alternative name when the Dane client ID is not sent in the extension. And there is also a possibility to do authorization rules to allow different connection or to deny them based on the client ID and some mechanism that you want to implement. And for the Dane client ID extension, as I mentioned, we've implemented the TLS 1.2 and TLS 1.3 extensions in the Golang TLS library. So that is working. And to test our implementation, we built, we used our use case in IETF, so using LoRaWAN. So only focusing on the IP space, there is a bunch of peers that are authenticating themselves using mutual TLS. And the basic problem that we have with common web API is that we have to share a common CA. And so that is restraining ourselves to a kind of silo environment. So, so this is the architecture that we had before with a single root CA that is shared among all the peers. And this is what we have now. So we are basically authenticating all peers using DANS, so Dane, and with the client ID extension. So that's that, and that is working well. So we're kind of happy of that, about that. Thank you. If you have any question, I'll be right there or whatever. Thanks.
Okay. So the next one is GNAP. Okay. Or is it GNAP?
Yes, it's one of those.
Okay.
Or it could be other things. All right. Hi, everybody. I'm Justin Richer, Aaron Parecki, and we've only got like, what, 28 slides? So this will be quick. All right, so GNAP is a delegation protocol, a lot like OAuth, and in fact, it's based on a lot of the things that we've learned about over the last decade of deploying OAuth in lots of different circumstances and situations, and trying to kind of do that type of protocol newer and better. Won't get into the details of exactly what it is. It's an ongoing working group. Our focus for this hackathon was to build stuff. We wanted to make sure that we had the ability to protect requests with HTTP signatures and validate those requests inside the GNAP protocol. We wanted to be able to get tokens from those requests, usable tokens, and make sure that we could actually launch off different kinds of user interaction, because the whole point of a delegation protocol is letting a user delegate some set of rights that they have to a piece of software. All right, we built a bunch of new code. We now have 4 different functional client systems on different platforms, PHP on both CLI and web. We built an SPA client completely in JavaScript, and we made significant updates to some existing code that we had for a Java-based web client and the Java authorization server. We leveraged as much existing code as we could, especially for supporting standards like HTTP signatures, structured fields, and of course, native crypto primitives. We weren't writing our own crypto libraries to make all this stuff work. And we've got a list of the stuff that we used and other things that are available that we collected in the lead up to this on the working group wiki. We learned that HTTP signatures is pretty complex to do from scratch, but it's the kind of protocol, it's the kind of system that once you have it done in your platform in a library, then you can sign any HTTP message. So it's kind of like once you have a library on whatever you're building, then you're pretty much good to go to use it, whatever. We both saw that same kind of hump that once we got that piece going, the rest of the protocol, the rest of the GNAP protocol actually kind of fell into place pretty easily. We were surprised by some of the fiddly bits in terms of like parameter order and stuff like that, which if you've worked with any security protocol, you know that that's the kind of stuff that happens. And we found that it is actually very possible to implement several GNAP clients from scratch in relatively short order once you get over the humps of the basic dependencies. And I learned that after all these years, I still really hate JavaScript. We took, that wasn't a secret, Hannes. So in the course of this, we took a lot of notes about different ways that we can improve the spec. We wrote this down mostly for our own benefit so that we can take this back. I'm not going to go through everything here, but we found a lot of places where like, oh, this is a little ambiguous, or Aaron implemented something in some way that was different from how I did it, the kind of stuff that a hackathon is supposed to really give you. And we now have a canned set of demos for all the stuff that we did. So this is the web-based Java client. A bunch of different configuration parameters for using the GNAP protocol and all the signature stuff. That creates a pending grant request, which you can then approve at the authorization server. These are two different pieces of software talking to each other. Like most security protocols, it's really boring when it works because stuff just happens and it works, but there's a lot of stuff going on in the background here, I promise. So this was our debug console showing some of the messages. We also had, like I said, an SPA client that we wrote pretty much from scratch during this weekend. This is entirely in browser. Even the key generation is using the Web Crypto API. So this all runs completely in browser. Same kind of thing, goes back to the same server and gets back the same set of information. And this is a hackathon, not a production-a-thon, so that CSS is all screwed up. Ignore that.
I was working on the PHP side of things, so I have both a web server base and command line. I did not use CSS. This is just HTML in the browser. You know, you click login. It's showing you the response it gets as I was debugging this. Go approve the request at the authorization server, get bounced back, and surprise, surprise, you are signed in because you have an access token. On the command line, it looks a little bit different. You start the request on the command line. You can open a URL in your browser or scan a QR code on your phone, which then opens up that familiar looking authorization server approval screen, which since you're now on two different devices, the phone is just like, go back to the command line and finish there. In the meantime, it's been polling and then gets the access token after it's done. So it's like Justin said, pretty boring when it works, but all the fun we had was when things were not working. So yeah, that's it. All right, thank you very much.
Thank you.
Okay. So the next one I have here is HTTP transport off. Okay, great. Share. And oh, let me make it full screen here.
Just left and right. Huh?
Yeah. Yep. Good. Seems to be working.
All right, very good. I'm David Oliver. This is Hans Christoph Steiner over here. We're with the Guardian Project. We do civil society work. And for this project, we dusted off initial implementation of HTTP transport off. The draft ID is here. And unfortunately, we had a student work on this during the COVID time who had some real personal challenges being apart from his family, et cetera. So this unfortunately went dormant for a while. We decided to pick it up and get it working in Conscript so we could open source it and document it for the public. As a reference for why we would be interested in doing this, we have a case where we want to authenticate traffic that isn't just request response. And so we want something that runs alongside normal web services and can authenticate a TLS session without leaking information in the client hello. So this is a technique for pulling information out of the TLS connection, common to the client and the server, and using that to encrypt credentials in a way that flows with the HTTP connect flow. On success, you get 200 connection established, and on failure, you get 400, 405 method not allowed. So we were able to get this working in Conscript, quite a pile of stuff to get working for just a very thin shim. And so that was great. We also mapped out how this could be implemented in Python and Cronnet. We aren't aware of anyone else doing this work, so we're sort of looking for an interop partner. We don't have a full proxy flow. We were not trying to rebuild some proxy service on the server side, so we're possibly waiting to get our Python work done before we start doing that. The GitHub repo is here. We were curious about this keying materials export function in the TLS layer, and we did discover that languages that implement OpenSSL or boring SSL generally make this available. Python currently only gets it via PyOpenSSL, a secondary library, rather than native, but there's an open issue for the language. Go exports a function for this, Rust, Microsoft, and Mozilla. So we felt really good about places, other methods, other language systems we could use to implement a function here. So here we are, David and Hans from Guardian Project. There's our URL and pointer to the draft in our repo. That's it. All right.
Okay. Kind of forgot that we usually let people ask questions too, which I guess we could try to do as well. Although I don't know if the Meetecho Lite client is available. So for people in the room, if you have a question, maybe just raise your hand. People online, if you throw something into the chat, we can transfer. We can, have you ask questions that way. The next one is I2NSF, which I know the presenter is remote.
Hello, Charles. Can you hear me?
Yeah, sure, I can. Do you want to, let me see
Sure.
if I can let you drive the screen share here. There's a way to do that, I believe. Or do you want to show the slides yourself?
Yeah.
Okay. So you can just request to share slides. Oh, I see, you are.
Yeah.
Okay, I think I need to stop this first. And then, there we go.
Okay. Can you see my screen, Charles?
Not yet.
Not yet. Okay.
It says it's starting. Just give us a minute.
Sure.
Did you select which application you want to share? There you go.
Okay. Okay, here you go, right?
Okay, let me just put you full screen. Okay, you should be able to drive it now. Yep.
Okay, so, okay, let me start, okay? So, hello. Okay. Okay. So, okay, let me start. So this is Jeon Porjong. I'm champion for I2NSF project. So Patrick, Jonghyun, Charmin are my members for this project. So this is the poster for our I2NSF Hackathon project. But basically, our goal is reflect latest revision of our I2NSF data young model draft. Okay. This is the network topology for I2NSF Hackathon project. So basically, okay, I2NSF user delivers a high-level security policy into security controller, and the security controller translates receive the high-level policy from I2NSF user into low-level policy that can be understood by network security functions such as time-based firewall and web filter, and that we can defense from the attack, okay, from outside. So all existing interface have been implemented. Also, we reflected the latest version because our I2NSF working group are working to publish young data models such as the capability, consumer-facing interface, NSF-face interface, registration interface, NSF monitoring data models. Okay. Also, we introduced a new application interface data model to give feedback message from NSF monitoring data. Okay. So we want to make automated feedback system for security services. This is a screenshot for application interfaces, okay? So we can give a certain attack IP addresses. So those IP addresses can be blocked by time-based firewall later on. So what we learned this time, we updated the data young model to make configuration less complicated and less confusing. Secondly, new monitoring data model can provide multiple the information pieces in a single notification. Previously, we have separate notifications, so we can reduce the bandwidth. Lastly, we introduced the application interface to enable automatic policy feedback, so we can provide the problem information to security controller to help identify the region of the security attack or system overload, something like that. So this is so we previous old complicated compilation into the more simplified version this time. Also, previously multiple event notification consolidated, which means merged into one single notification. So we uploaded our open source project GitHub, so you can download our program from this GitHub. So this is lab up. So this time our Korean teams, including I2NSF team and IPWave and BMW Hackathon teams, we gathered together in Busan in South Korea. So we work from Wednesday to Saturday. Okay, thank you for your attention. Yeah. So any questions or comment?
Okay, yeah, I don't see any questions in the room here. And thank you for that presentation. I'm not sure if your slides are up for next, but why don't you just go ahead with the next presentation?
Okay,
IPWave, you have a second one. Yep.
Yeah, sure.
We can just do it now.
Okay. So, okay. Charles, can you see my slide, right?
Yes, we can.
Okay, great. Thank you. So second project is the IPWave Hackathon project. I am Jae-won Jung. My co-members are my PhD student, the BNME, Boga Parigira, and my doctor researcher, Chris Shan, and my PhD student, Hyuna Jung and Juni Kwon, and okay, our intern student, Gilton Choi from Busan National University. So this is the IPWave Hackathon project. But basically, we used wave protocol. Left-hand side is the TCP/IP over. Previously, we used the I2P wave. Now we use the 5G V2X. So also we implemented the context-aware navigation protocol among vehicles. Also this time, we enabled the communication between drones. Okay. So we have two parts. First part is a simulation context-aware navigator protocol CMP for drones. So previous IETF 112 hackathon case, we implemented the context-aware navigator or protocol for vehicles. Now, IETF 113 case, we implemented the CMP for drones. Okay, drone is a promising area for unmanned error vehicle. Okay, so second part is also we implemented the drone assisted handover mechanism for vehicular networks. Basically, you can see in 5G case, G-Node B is a base station for 5G edge network, so can cover highway for vehicles. But certain cases, there is some coverage holes. In that case, we want to using UAV, unmanned error vehicle, such as the drones. So drone can play of a role for the moving or mobile base station to cover these vehicles. So basically, this time we implemented this kind of drone-based handover mechanism, such as the vehicle is go out of the communication range of G-Node B, and then it can continuously served by UAV, and then this moving to another coverage of a G-Node B, and then the vehicle can connect to next G-Node B. Okay. So we implemented our draft IP wave context-aware navigator protocol for drones. Okay, so this time we didn't complete the implementation of a drone, but we will continue for next 1-on-4 hackathon complete this simulation part. Currently 60% implementation for drone V2X. 5G V2X is implemented for our vehicle mobility information option. Secondly, the drone assist handover mechanism case, the basic goal is improve accuracy of a handover decision using Kalman filter. Basically, the beacon message from G-Node B or the base station, and that we can decide the handover time. Considering the signal strength from the previous base station and new base station over drone. Drone, remember, is moving base station. This is the simulation environment. Okay, so we have a rotor network. This is a base station, G-Node B or E-Node B. So 5G case is called G-Node B. 4G LTE case E-Node B. Okay. So basically, we want to implement drone communication to avoid the collision among drones, and also we can support handover. Okay. So what got done this time? So the Simu 5G is a simulation for 5G V2X simulation module. So we integrated that module into OMNet network module. Okay. Also, we try to enable IP version 6, also IP version ICMP version 6 for our IP wave context-aware navigator protocol. Okay. Also, this is the network simulation topology for handover. So this is network topology, and also we used OMNet++ to support the drone-based handover. Okay. What we learned this time, the first time context-aware navigator protocol CMP is using ISMP neighbor discovery message. It is called BMI option, vehicle mobility information option, to share vehicle direction, speed, position, something like that. So we saw the possibility of sharing drone mobility information for drone collision avoidance. Secondly, drone assisted handover. So this time drone handover is completed based on IP version 4, but my student are working for IP version 6 version. So we didn't finish yet, but we will continue to finish this one for next IETF 114 Hackathon project. But the accurate signal power measurement from node B, and then we can increase the accuracy of handover decision using Kalman filter. Also, we try to using deep learning algorithms such as long-term LSTM mechanism. This is a project a GitHub link. Okay, so we uploaded our implementation code into this GitHub. Okay, this is the portal for our IPWave team. Also, Professor Yang Kim from Sungsil University. He is the champion for BMW working group. He's a student and my student. Okay, thank you for your attention. Yeah. Any questions or comments?
Okay, yeah, thank you. And as was mentioned in the room, thank you for staying up late and to present to us here.
Okay, thank you, Charles.
Question if we do have questions.
Oh, looks like there is a question.
Okay, go ahead.
Oh, so the slides are, I believe they're uploaded into GitHub already. Yep.
Got that. And if you have additional questions for a particular speaker, such as that previous one, is there contact information available?
Paul, is your contact information available on the slides?
Context aware navigator protocol?
No, just to contact you if people have questions and they want to contact you
Okay,
offline.
email address.
Yeah, is it in the slides?
So okay.
Oh, it's in the
slides
wiki.
is-
Okay. Yeah,
Wiki, yeah,
you're
wiki, yeah, you
listed
can
as the champion for the project. So in the wiki, I guess your email address
Okay.
is there. Okay. Yeah,
Okay.
thanks, Paul.
Thank you.
Okay. We may need to do a little debugging here because there's some echo. Did you guys want to do something before I start the next one?
Just check if your audio is muted. Can you click on this? Just to
Okay, let's do this.
this icon
Yeah.
here.
Let me
Dismiss
get out of
this.
here.
Yes, dismiss this. Then click here. Okay.
So now it's on. Right?
Okay. No, now it's off.
Ah,
okay.
Okay, so that should do it. Okay. So red means on and green means off, I think. Sorry, I'm learning. I had it mixed up. Okay. So next up, at least the one I have here, I believe we covered those. Is that right? Yes. So BMWG. Do we have anyone here from BMWG or maybe you're remote? Okay, you're there. Okay. Do you want to? Okay, I'll let you share. Hold on just a sec.
Okay, can you see my screen now?
Okay, great. It's all yours. We can see your slides here. Can you hear us?
Yes, of course.
We are not hearing you. Do I need to?
Hello?
Okay, so it sounds like you're very faint. I believe I hear you just a little bit.
So it's better now? It's better now.
Yeah, you're still pretty faint. Is there a way for you guys to increase his volume? Yeah, we don't hear you anymore. Are you there,
Hello.
Tran?
Can you hear me? Because hello. Sorry.
If you want to try requesting to share your screen and the audio, we can do that again.
Hello, can you hear me now?
Still don't hear you.
Oh, can you hear now?
So Charles, this is a part in the computer. We can hear the Tron. Looks like you cannot hear his voice, right?
So maybe I need to, no, this shouldn't matter, should it?
Hello.
Ah, okay. I was going to say, because it looks like Miteko's happy. Yeah, so we just lost audio in the room. Request to share. That would work out better. You're Jordy? Okay. All right.
Hi there, this is Lorenzo from Miteco, just testing that audio injection works fine in the room. Can you hear me? Test. Test, test. Toby sto parlando, eh? Test, test.
Okay.
Test.
Yeah. So yeah, thank you very much. I'm Jordi Rajiral, and on behalf of the Alto Working Group, and yeah, I'm going to present our hackathon using Alto Cos Maps to optimize data set transfer for LHC, the Large Hadron Collider. Yeah, just starting with a very big thank you note to all the people who actually participated in this hackathon from the Alto Working Group, working endless hours managing 3 different time zones for the last 2 weeks, actually. So thank you very much. Yeah, so actually this hackathon is for us sort of like a kickoff, because we are starting an initiative within the Alto Working Group to create what we call the Alto Code Base project, basically, which aims at providing a parallel track to the working group's standardization effort towards implementing the features introduced in the latest RFCs, basically. So the hackathons will be used as 3 checkpoints a year to test interoperability and the latest capabilities implemented from the protocol, basically, to collect feedback and sort of socialize some of the latest ideas as well. So yeah, so we, the goal of this effort basically is to actually deploy Alto and develop the code base closely connected with production applications. And in this hackathon, actually, we focus on one of them, which is the integration of Alto with the Rusio application, which is an application used by scientists at the LHC and globally to transfer large-scale data sets from Geneva and sharing those data sets globally, basically. Yeah, so with we welcome people to actually join us, and we're going to be, in between the hackathons, we'll be creating teams, epics, using a Scrum and coding, basically, to get the code running, basically. Yeah, so the goals for this hackathon, yeah, so the goal is to use Alto Cos Maps to optimize dataset transfers for Rusio. Rusio is the application, like I mentioned, used by scientists to share large-scale data sets. The focus is on integration of the Alto northbound interface with Rusio to provide better visibility to the application to make better decisions. So Alto basically provides the state of the network, provides some bandwidth availability or latency from the network, depending on the sort of the dynamics of the network, and then provides that information to the application so that you can make better decisions on how to, upload or download these large data sets, basically. Yeah, so the RFCs involved in this hackathon are in this slide. What got done? So basically, implementation of an Alto client in Python, based on RFC 7285. Integration with the CERN Rusio replica download. We actually, out of this hackathon, we actually submitted a pull request against the Rusio open source project. So that's going to extend that with the capability to actually be able to choose the algorithm upon which you make those decisions on where you download the replica from based on network conditions, basically. We work on 3 demos, basically. Then I'm going to just touch on them a little bit. And then also extensions on southbound Alto integration with SDN controllers, with Mininet and Open Daylight. You have a Scrum dashboard that you can actually access. It's open, so you can see what's going on also. And yeah, lots of really interesting conversations. The Open Alto project, that's the architecture. I'm not going to go into it. You have the slides. You can actually look at it. But basically, there's a northbound API that interfaces with the applications, which are, really a lot of different applications, but it's science applications or 5G edge computing, CDNs. And then on the southbound API interfaces with networks, any kind of network really, and typically interfacing with an SDN controller, whether it's in the edge cloud or at the backhaul or anywhere really. So yeah, the metrics that we use for this hackathon, if you look at this iDraft, which provides a table of all the metrics that we focus on for this hackathon on the round trip delay and available bandwidth. Demo 1, the goal here is to be able to make smart decisions on where do I get my data from. Suppose you are a scientist and you're trying to get a huge data set that needs to be globally transferred, and you have different replicas you can choose from. So you just want to know, right now, what's the best choice I can do? And so Alto is an abstraction layer that provides that kind of information. In this case, what you see is step 1, look up the host by finding the longest prefix match. Step 2, bandwidth between hosts as the Alto host cost. So Alto, you query the Alto and you get the sort of the bandwidth cost map for each of the endpoints you can choose from. Step 3, you get the replicas back from the Alto service ordered by the bandwidth availability. Suppose you want to choose the highest bandwidth because you want to minimize download time. And then step 4, you get you choose the replica, you choose where to get it from, and you actually can get an estimate of the throughput from the system. Yes, this is actually some of the results from the demo. You can see that if you use sort of what the scientists do today, which is sort of like an agnostic decision without knowing what's going on in the network, you would get certain performance. But if you are aware of what are the link capacities and what's the path that you're going to be choosing, what are the network conditions, then you can do better. So here you see 4 to 5x speed up in the simulations that we ran over the weekend. Basically, this is running on Mininet, basically, so simplified environment. The same thing can be done based on latency, so I'm not going to go into it, just some experiment where you choose based on latency. And then I have 2 more demos we actually put, an Alto estimator, multi-flow throughput bandwidth prediction, and demo 3, an Alto scheduler, which allows you to do SLA constrained multi-flow node selection. So suppose you have certain requirements to guarantee, say, I want to get my data transfer by 5 a.m. tomorrow because I need to work. So please give me sort of the replicas that I should select, and from so that I can meet my requirements. Say so. This demo number 3 is half baked, but we're almost close to actually finish. Yeah. So yeah, thank you very much. So welcome anyone who actually wants to participate in the project. If you are a developer, so you reach out to us. You have here some resources in the slides, and yeah, looking forward to seeing you in Philadelphia. Thanks.
Okay. So, oops. Sorry, that's not what I want. Okay, let's see what we got next. How about SodaStream? Great. Okay, looks to be working. Yep, so I am Stephen McQuiston from the University of Glasgow. I am with the SodaStream project. If you're not familiar with that project, basically it is aiming to improve distributed decision-making in large organizations, so using various data mining techniques to do that. We're essentially developing those techniques using the IETF as a testbed because there's lots of decisions being made and lots of information around that decision-making process is publicly available, and so it's a great way of testing out these techniques. So to try and accomplish our goal, we need to better understand decision-making within the IETF. So, who's making decisions, where are they making them, how are they making them, and what impact do those decisions have onto the day-to-day running of the IETF. Our previous work has looked at RFC deployment and the factors that influence the success of protocols and their deployment in the wild. Our more recent work has looked at the IETF social graph, so who makes up the IETF and what are their participation trends. For this hackathon, though, I've been looking at analyzing RFC errata to sort of motivate why you might want to look at RFC errata. Previously, we've seen that RFCs can take a really long time to get published. So this plot here shows the number of days from the first draft to publication of the RFC itself. And we can see that not only is it an increasing trend, but it's taking a really long time. So the median in 2020 was over 1,000 days. Despite this really long drafting and editing process, we also see that there are still errata being filed against RFCs. So the trend over the last decade or so has been around about 300 errata being filed each year. And so our question then becomes, in spite of this multi-month or multi-year editing and drafting process, why do errata still occur, and what can we learn from those errata that might inform our learning about RFC authorship and the process behind it. So this week at the hackathon, I've been developing tooling to explore this dataset and trying to analyze the sort of initial trends that we can see. So thinking about the kinds of RFCs that contain most errata, this plot shows errata filings broken down by area. We can see a couple of outliers. The former application group area, rather, and the security area both have most errata per RFC across all the areas. Now, ultimately, we don't know why yet. You could conjecture that security RFCs contain sort of intricate algorithms and pseudocode, and that lends itself to containing more errors, but we need to explore further. Thinking about how long it takes to identify errata. So this is a CDF of days between publication of the RFC and errata being filed against it. Around half of the errata are filed within 1,000 days after publication. Essentially, we think this is a proxy for the popularity of the RFC and how widely it's being read and how widely it's being deployed. But again, we do need to explore this further as well. Now, naturally, you might want to think about what kinds of errata are being published. What's the nature of the errata that are being filed? Now, the dataset as it stands, as it's maintained by the RFC editor, isn't particularly granular. We have two types of errata, editorial and technical. And again, there's a sort of fairly stable trend whereby about 40% of filings are for editorial issues in the RFCs and about 60% are for technical problems. Now, one of the main things that I've worked on is a way of sort of expanding this data set to be a little bit more descriptive about the errata that are being filed. We've developed some tooling that allows people to go on and view errata filings and tag them with more descriptive labels. So you can see some example labels here. So typos, terminology mistakes, is it a mistake in the diagram, et cetera, And so I'm going to finish with a pitch for people to visit our website, use our tooling. You can break the errata filings down into working groups. So if you go along and find the working groups that you're active within, you can look at the errata filings within those groups. And if you can help us out by adding more descriptive labels for what those errata filings are saying, ultimately, it will not only help our research, but we will make the dataset public after it's done as well. So please do visit the website and contribute some labeling if you can. And I'm done. Thank you very much. I think we normalized by page count, which is not excellent, but there is some normalization going on. All right. And my assumption was this was for accepted errata only, not for looking at accepted and unaccepted. So we are looking at all filings. There's a bit of an issue in the data set in that there's lots of filed but not dealt with errata. And so if we start to sort of separate that out, we're losing a lot of the data set. But yeah, we will look at the status as well. Yeah.
So your first curve where you said it's taking longer to get RFC, sort of would be explained by the fact that there's, you know, the old joke about having to create the world in 7 days because there's no installed base. You've got to deal with the installed base problem.
Yes.
So have you tried to account for that in any way, shape, or form by looking at essentially what the back observation needs to be in terms of working groups? Because it's not clear to me that you can necessarily squeeze it down, that it, by nature it might be an expanding problem space.
Yeah, so that's not the purpose of this work, obviously, but we do have a paper on that looks at that sort of trend and looks at, you know, whether RFC was building on prior RFCs, and obviously that might mean that it would take longer. And we did explore the trends behind that. And I'll
So you're not necessarily criticizing the folks in the room?
No, absolutely not. Definitely not.
Why not?
I don't want people to throw things at me. Yeah, but happy to share the details. Yeah.
No insulting.
Okay, thank you very much. Okay.
That's the remote audio. Can you hear this?
So let's
Blah
see
blah
what's
blah.
going on.
Test. It sounds worse. It sounds fine here, but test.
Hmm.
I guess
Okay.
so.
Do this again. So after SodaStream, let's see, we did DNS. What am I doing on that? Okay, good. Oh, let me make that full screen.
Right. Next. Oh, there we go. Yeah, so we had a lot of people again in the DNS hackathon area over there. And one of the things we did was extended DNS errors while implementing extended DNS errors. There were certain situations where we think a error code is justified, but no extended DNS error is yet defined. Maybe I should have explained what it is quickly. So a DNS error looks like there is a error, and extended DNS error tells you what the error exactly is. And so we discussed, so you see that the policy to register new info codes is first come, first served. So anyone can just register, but it would be nice if all the DNS implementations would return the same info codes for the same situations. So that's what we discussed. And there's a draft with the new info codes, and we discussed that among the DNS implementers. This is a new ID, dry run DNSSEC. It allows you to try out DNSSEC before going live with it, because that's a bit scary for many people, and rightfully so. And it does this, the idea is to have a new delegation signer algorithm, which just wraps existing delegation signer algorithm and just signals, this is dry run DNSSEC. This is the ID. If you have dry run DNSSEC DS in the parent, you're going to try that first. If it works, great, the answer is secure. If it doesn't, then you fall back to what the situation would be without this delegation signer. So if dry run is the only one, you fall back to insecure. If there are other situations, you fall back to secure, probably, but that way you can try out like algorithm rollovers and all sorts of DNSSEC situations. So this has to be backwards compatible. So what we did was run RIPE Atlas measurements with the new delegation signer. Unfortunately, RIPE Atlas had some issues, so there are no actual numbers in these Venn diagrams yet, but hopefully they will be there when DNSOP is happening. Catalog zones. We did interoperability testing. There's a new bind implementation for the version in the draft. And we created a table on the Hackathon wiki to coordinate which catalogs were served by which implementations and which other implementations consumed them. So there was a good progress there. Yep. And then indeed, finally, there was the, well, that's not completely correct, I think. Oh. Well, there was a dynamic update over encrypted transport. Unfortunately, this is not the slide, is not correct, but doesn't really matter. I can tell about it. So queries can go now over encrypted transport, and recently also transport over TLS and DNS. And this is an ID to also do dynamic updates over encrypted transports. And there's a server implementation for this now and several client implementations. There were a lot of people working on this online, so not in person. And they booked great success. Here you can see Benjamin Fry reporting success on the DNS over TLS dynamic update implemented in Rust. And then Tony Finch started recently working for IC, but decided to do some improvements for a Nelnet Labs implementation. So that's really great. Thank you, Tony. And yeah, what got done? Lots and lots of excellent conversation. The OpenDNS software developers met each other again since a long time in person. And we met with operators, and now there's nothing that can beat in-person hackathon like that. So that's what we learned. And that's it. So if anyone has questions, yes.
Thank you for this great presentation. The driver in DNS, is there a projected availability commercial products for that, or what's sort of the status?
The status is that it's just the ID currently, so no implementation. The
or RFC or something trying to get it to that?
Absolutely, yeah. The draft is on the slide. And I will present on it at DNSOP coming Tuesday. It's not yet a work group work, so we have to see if it's if the work group is interested in this. But yes. Thanks.
Okay. What do we have next? So, BMWF. Anyone in the room for BMWF? Is there a remote presenter for that one? We could try that again. I don't see anyone coming up, so I'm going to go to the next one. Okay, how about PDMV? Great. All right.
Hello, everyone. My name is Amiya Deshpande. I'm a student at NITK Surathkal. I'm the co-author of one of the co-authors of PDMV2. So PDMV2 is the version 2 of PDM RFC 8250. PDM is performance and diagnostic metrics. Basically, it gives you the information about round trip time, the server processing capabilities, and the sequence numbers in packets. It's sent as an IPv6 destinations option extension header. And we realized the requirement for securing this. So PDMV2 tries to add encryption to it. We divide this process into PDMV2 registration and the data transfer phase, where we send the actual extension header encrypted and the receiver decrypts it on its side. In the internet draft, we plan to standardize the data transfer phase. But for the hackathon, we thought we'll have a complete implementation starting from the registration. This process is kept, we propose a sample registration protocol, and we keep an option open for enterprises to implement their own registration protocol. So what we have done for the registration protocol is we have broken down into primary server, primary client, secondary server, secondary client. And in the hackathon, we focus on the primary registration, where we try to establish a shared context. We were having discussions on whether to have authentication, authorization, and how do we do it. So the planned solutions were, so for, of course, we need an authentication to share this information. So we rely on the standard established protocols, TLS, MLS for authentication. And then we have an allow list, which can have IP prefixes or client identities, which are derived from authentication. So what we got done. So currently we are working on a sample registration protocol, and it didn't have the facility for authentication and authorization. So we created a sample code for allow list, integrated it into the registration protocol. We did have conversations on how the primary key encapsulation mechanism should happen. We are using HPK for our encryption, and the registration phase basically performs the key encapsulation mechanism. Tomorrow we'll be showing a demo. We have a side meeting scheduled in Green Room 1, 8 a.m. What we learned. So PDM v2 is a new concept, and we would like to get a POC which works and which covers our complete idea. And registration, for the registration protocol, we were working on the key generation till now, and from yesterday we have been working into identity resolution, authentication, and the authorization process. So we look towards any user feedbacks and have a complete implementation, including registration and the data transfer phase, which we are proposing. So our team consists of Nalini, Mike, me, Tommaso, and we all are first timers at IETF Hackathon. So here's our email and draft link. Thank you. Any questions? Okay. Thank you.
Test, just making a quick test to check if audio injection works. Test. Sto facendo un test, Alex. Test.
All right, so we have just a couple minutes for a little bit of technical troubleshooting here, and then we'll get started again.
Testing, I'm talking. Doesn't look like they can hear me yet, but audio is supposed to go through, but it's apparently very low in the physical room there. So that's what we are debugging right now. Testing, just double checking, testing, test. Okay, looks like it's working, so I'll get out of the way. Sorry.
Okay, well, if only we could fix bugs in the hackathon that quickly. All right. So let's see, where was I? We are up to Cozy. Is that, oh, okay, Hannes, great. Yeah.
Hi everyone. That's a one-person project. I was this time. Previously, we were a bunch of folks, but due to travel restrictions and so on, just me here. I was working on firmware encryption, which is related to the suit working group and uses specifically working COSI some new work. And the plan was to implement the COSI HB key. HB key is the hybrid public key encryption, a key distribution mechanism. And the idea was to contribute that code of that implementation to the DCOSI library, which Lawrence is the maintainer for and implements or offers that implementation in C. So have a look at it, like to the DCOSI library in general. And I wanted to use an API called the BSA Crypto API, which provides an abstraction layer over different low-level crypto implementations, specifically abstracting hardware-related crypto features. And obviously, I was working on that. Got the encrypt and decrypt functionality done with this the DCOSI internal abstraction layer. That library offers the possibility to swap out different crypto implementations. Currently, there are two, one based on BSA Crypto API and the other one based on OpenSSL. So it's quite convenient to actually do that. Happy to be here to see some of the familiar faces again. Sitting next to Lawrence, which is obviously a big benefit, being next to the maintainer, one of the big benefits of having a face-to-face event rather than a virtual one. Made some good progress, but of course, I'm not done yet. COSI is not a terribly complicated specification, but still complicated enough for this purpose. So the content will be uploaded to this repository. And yeah, that was it. Two links to the specifications that are relevant. One is obviously this new COSI HB key functionality, and the other one is where it goes into to encrypt firmware for IoT devices. And that's all there is to say.
Should I make Hannes get back up here for questions? Any questions for him? Okay. And EAP, noob. Oh, great. Do you want to drive? You can use this laptop, or if you want to drive from yours, just you'll have to request the share. Oh, okay. We will do that.
Okay. Let's see. Okay, yeah, so I was working on EEP Noob and a new draft EEP Ute. My plan was to actually implement EEP Noob into the ESP development framework, ESP IDF for ESP 32, EEP Noob RFC 9140. And server implementation already existed from a master's project at the University of Bremen, where I'm currently in. What I actually did or get done is to have a first functioning code for EEP Noob, but not completely, mainly just the JSON and message parsing and checking for the correct format. It's not yet completely functional. The key handling and the cryptography parts are completely missing. Mostly because I had to figure out how ESP IDF is handling the EEP stack. As a side project or side work, I looked a little bit into EEP Ute, the one new draft I wrote to improve the or to achieve the same goals as EEP Noob, but with a different message format. EEP Noob uses JSON. EEP Ute will use CBOR. So that was a side project that I did at the same time. And that's actually all I did, because it took quite a long time to figure out ESP IDF. Any questions? Okay.
Okay. Okay, and then we have rare free RTR. So it looks like Barry converted your slides to PDF, so you can share from here if you want from yours. But you'll have to, you want to drive from yours? Okay, I'll just pull it up here. Yeah, great.
Looks a bit different than on my screen. I hope the pictures come out. Hi, I'm Simon from Switch. We are the rare free router team. It's a bit different in that we are not centered around IETF working groups or protocols, but around an implementation. So what is rare and what's free router? Oops, sorry. Next. Doesn't work. Oh, sorry, forward. Ah, thanks. So free router is a Java-based user space single process implementation of many, many routing protocols, including MPLS and BGP, OSPF, and so on, and some new ones like AMT for multicast that have been in existence for a couple of years. RARE is a project funded by the EU under GEON, so the research networking community in Europe, that tries to make this useful in research and education networking contexts. And one of the things we did is to add support for some data plane backends, including the P4-based Tofino platform, which is interesting because now we can connect this open source user space routing control plane with very high speed data plane cheap routers based on some chipsets that support P4 and build some real interesting routers. And what we noticed is that this platform has become interesting to some people with special needs from our research community. And we have a couple of them here. So Polka is a new source routing or forwarding paradigm that will be presented here on Thursday by two colleagues from our team from Brazil, actually, that has been implemented in free router, including the P4 data plane implementation. Exciting work. And another example of these special uses is also represented here by Carmen from CERN, where some physicists reminded me of the Alto talk, try to solve some other problems of their very large data transfer needs by marking flows using the IPv6 flow label and doing traffic engineering based on that. This is something that normal routers don't do because they don't use flow labels for that, but it's fairly easy to implement if you control the platform. So that is also something that we have nice working code for on this platform. So we haven't been working on actively developed protocols in the IETF, but of course, some that were implemented or that were defined before, and some that might come to the IETF in the future. Who knows? So the plan was mainly to bring our community together because the people who joined the project over the past years, we never met in person for various reasons, well-known reasons. And so we prepared a large list of potential projects, most of which we can still move forward to future hackathons because we worked on some completely different stuff. And of course, the images didn't make it, so maybe I should have shared my phone, but it's, well, anyway, so we did do some implementation. The first small thing we noticed is that the developer who had free router as their laptop platform gained IPv6 connectivity immediately here, but IPv4 wouldn't work because the IETF network DHCP server sent an option that free router had trouble with. So that was the first like warm-up exercise to fix the platform to understand that kind of option, which was interesting for the other community members to see how quickly such a small fix was implemented. And then we spent the rest of the time mostly working on one big feature, which is unicast RPF. So it's a check for against spoofed traffic based on routing lookups, basically of the source address as opposed to the destination address. And there was some code that existed in the control plane side and for some of the data planes, but we added the P4-based fast hardware implementation of this. And that turned out to be extremely interesting to the newcomers among us, because we had to, okay, so if it's possible, yes.
Yeah, if yours is working.
So I asked for, sorry about this, there should be some images here. Okay. I did. Okay, you really want to share? Yes. I hope it lets me. Oh no, I think I missed a. Okay, bear with me just a second. Okay, that looks a bit better, huh? Okay, so these were the things we did. The most important thing is probably the last image, because we did manage to bring at least a part of the community together and provide like the social basis for a good collaboration in the future. Unfortunately, not all of us could make it here. Some had like COVID or family reasons to stay at home. Okay, so this unicast RPF feature, it was very interesting to us because it touches all the components of this free router system, including data planes. First of all, the configuration. Here you see the typical way it's configured on an interface. You ask for this verify source that's compatible with industry standard routers. There are a couple of variants that are described in different RFCs, and is actually ongoing work to refine this some more. So this also lays the basis for implementations of new IETF standards that may come up. But the tricky part is actually the mapping to the high-speed forwarding plane. So as I said, basically you just do a lookup in the normal forwarding table, but based on the source addresses rather than the destination address. Only the forwarding hardware does not permit you to do two lookups with different keys in the same table. So what we actually had to do is to create new tables, which are basically a copy of the normal forwarding table, just for this RPF lookup. I think some people dealing with some high-speed routers know this issue, typical feature that cuts your routing table capacity in half. So this had to be implemented, and we found some interesting issues with this, actually. So it became quite instructive. So all of us got a good glimpse into the development process for free router. So we know now what's involved in adding new features, especially ones that have data plane impact. So it's a good basis to implement more protocols that you folks may be creating. One other thing we noticed is that the IPv4 implementation of this URPF check worked kind of right away, a naive implementation, but for IPv6, it took quite a bit longer. And the fundamental reason was that people 25 years ago, they just decided it should be simpler to fold the neighbor discovery protocol into the IP protocol. Whereas in IPv4, it's a separate protocol, this is ARP protocol. And it turns out it looks like a nice idea, but actually makes all these, it creates a bunch of exceptions that you have to deal with. So maybe this is a useful conclusion. It's not always like worth saving the number of different protocols. Maybe it's sometimes better to have an additional protocol that does one thing well. Anyway. Water under the bridge, we are not asking for IPv6 to be changed, don't misunderstand us. That was, no. Okay, so that was our team. For us, it's It was the first time to propose this project at the hackathon. Hopefully we can come back, maybe not in Philadelphia because most of us are Europe-based. Actually, 2 are from Brazil. Also, thank you to the IRTF who made it possible for at least one of the Brazilian colleagues to come by means of a travel grant. IRTF has these like diversity travel grants. It's very nice. It helped us a lot. Yeah, most of us are also IETF newcomer, all except for me. And yeah, please have a look at the web pages about Free Router and Rare. Bless you. And this, if you're looking for like a second implementation of your exotic protocol, talk to us, talk to Java, the Free Router main developer. Sometimes we can implement new protocols and new features very quickly because it's a relatively compact code base. And yeah, thanks a lot for your attention. Thanks for the nice work during the hackathon. And the presentation is on GitHub.
What do we have here? Okay, so now I think there's a few presentations we missed. So if you have a presentation that we didn't get a chance to do, if you're remote or in the room, maybe just request to share, and I'll grant that, and then you can share. Whoops. Okay, and Vladimir, you'll be next.
Hi. Can you hear me? Okay. Let's see. Do you see the slides now? Can someone confirm that the slides are visible?
Nope, your slides aren't there. Maybe, yeah, we actually had slides. Anyways, go ahead. If you request slides again.
I share the screen. Let me see.
That's fine.
Ask to share screen. Great. Do you share? Yes. Okay.
Yeah, we don't see him yet. Looks like it's still asking you. Okay.
How
now
about
you're
that? Okay. Short presentation about the project. We are working on a model for managing network tester. And that's part of the benchmarking working group. So this project has been going for a while. There is a draft which is currently going to be reviewed by the working group and hopefully adopted. So the goal of the draft is to allow development of benchmarks and tests using a young and netconf interface to the tester equipment. Until now, tester equipment has been proprietary mostly, but netconf and Young allows development of IETF-based interface. So the project is complex. I'm not going to go into details, but you can see in the slides all the repositories used. And if you have interest, you should go into the details yourself. So this is how the implementation that implements the model in that draft looks like. That's what we use for our work during the hackathons. And this is the design. As I said, I'm not going to go into the details, but it is possible to find what you need from this slide. So we have a programmable logic device, and we have a software that controls it. Everything is open source, including the hardware. So this particular hackathon, we ended up with the WAST of the RFC 2544 tests. In section 26.6, there is a reset test, which is means to measure how fast network equipment recovers after power cycle or turning off the power. So this test was a bit different from everything else because we required control of a relay actuator to turn off the equipment. And it was a bit different, so it was fun. We made this ancient HP relay actuator work with Young and netconf by adding a Raspberry Pi and a hat that controls the GBIP interface. And we could have not done that, but it was fun. So we wanted to use only Young and netconf to manage all the aspects of the automation of the test. So this is the end result. We added the necessary code to the Python script, and we also added that as an additional device to be orchestrated with Young and netconf. Yeah, so.
It looks like you're speaking, but we don't hear you anymore, or maybe you were done, I hope. Okay, we don't see your slides yet. Okay, they're coming up now.
So can you see the slides?
Yes, but they're, if you could put it in presentation mode, it'd probably be a
Yeah.
bit big. Yep.
Okay, so hello everyone. Yeah, this is Tufan. So I will give a presentation about our hackathon project adaptive subscription remotely. So the background of this work is that although the telemetry has increased the frequency of data collection dramatically, but it also incurs more resources at the same time. So people sometimes may find it hard to balance the need for the low overhead and the desire for representative telemetry data. So our proposal is to install the adaptive subscription policy, which is built on top of the YARN push mechanism and allow the server to switch to different period intervals based on the network condition changes. And our focused text scenario is the awareness network performance monitoring. The objective is to monitor KPI changes at different frequencies of data collection and also evaluate the performance of adaptive subscription. And actually, this work is related to an individual draft in netconf working group. So about the text scenario, we use the gRPC-based telemetry to collect data from access points, the network devices in our campus. And we have evaluated the following data collection methods: a high frequency periodic telemetry, a low frequency periodic telemetry, and an adaptive frequency telemetry. And also for each data collection method, we have evaluated two cases. One is to report the RSSI values so as to detect the real-time Wi-Fi roaming across different APs. And the other is to stream the bytes sent from the AP uplink so as to detect the potential link congestion. And we also use the ELK to collect, analyze, and visualize the data. So in this case, we have collected and aggregated RSSI signal data from different APs. And by default, the roaming RSSI threshold is -65. If the actual signal strength is less than that threshold, then the terminal will search another AP to attempt roaming. So in this case, we try to figure out when a Wi-Fi roaming event happens during the movement of the terminal devices, and also identify the continuous signal degeneration. So the results show that a very high frequency collection is easy to identify the important events, but also at the cost of a greater volume of data. And unsurprisingly, the low frequency data collection is at a 30-second interval, it's hard to detect the event and data actually. And also we tried adaptive subscription. There are two different ways to compare adaptive subscription actually. One is to evaluate the condition and make the decision of adjusting the period at the subscriber side. And the other is at the server side. And the results show that for the first way, it prevents the subscriber from capturing roaming events which last only 2 to 4 seconds, which is incomplete actually. While the second way, the server will evaluate the condition at the end of each high frequency interval. There's no important events and data will be missed actually. So in the other case, we have tried is to stream the bytes sent from the AP uplink to detect the possible congestion. And similarly, adaptive frequency data collection is able to capture as many traffic bursts as possible while keeping a low frequency of data collection when there is no potential congestion. And the link chart at the bottom right of the slide has shown that adaptive subscription can greatly reduce the amount of transmitted data compared with high frequency data collection. So the lessons we have learned is that we learned that the adaptive subscription can greatly reduce the data volume during the massive data collection and processing. And it can also serve as a compromise between the data management resource cost and data fidelity for network devices. But it's important to remember that the selection of the threshold for the specific monitored data object is really important for adaptive subscription, and it should be based on the operation experience. Okay, so and finally, I'd like to give my thanks to my teammates. We have Kun from Hunan University, Zhixiong from Microsoft, and Peng from China Mobile, and Wei from China Telecom, and also to show my thanks to my Huawei colleagues. So thank you. Thanks for your attention.
Do we have any questions? Okay, thanks for that presentation. Yeah, I don't think we have any questions in the room. So, Tran, you are up next, and then I'll just keep working my way through the queue.
Can you see my screen now? Can you hear me?
Yeah, it looks good. We hear you too.
Okay, thank you. So this is a result presentation of our benchmarking working group about container infrastructure benchmarking in this IETF 113. So first of all, I will introduce briefly about our graph. So our graph is a consideration for benchmarking network performance in containerized infrastructures. There are two main features inside our graph. Our hackathon activity first to verify the various network model of the container infrastructures. And the second thing is verify different configuration settings that can make an impact on the performance of the container network. So this is what we have done so far in previous hackathon. So this is a networking model and the performance impact that I mentioned about. So in previous hackathon, we have already made benchmarking about the kernel space, user space, and Sparknik. And we have done a performance impact about CPU isolation and Luma alignment. So in this hackathon, we focus on the service function training. We have do a little bit in the previous hackathon about the VVT multiport. And in this one, we focus on the combined model of SROV and VPP, and we also want to figure out the impact of the number of VNF in the service function chaining. So this is a benchmarking scenario. So we use a SROV combined with the VPP. SROV will be used for north-south traffic, and VPP will be used for east-west traffic. And we will test in two scenarios. The first one is single node, and the second one is a multi-node. And inside the single node one, we will increase the number of ports from 2 port, 4 port to 6 port to test the impact of the number of VNFs on the service function chaining. This is a scenario for multi-node. So each node will have 2 ports, and we use layer 2 underlay to connect between 2 nodes. This is the testbed of our topology testbed. This is the configuration of our testbed, and this is the result. So what we learned in this hackathon is, based on the result, we see the SR, IOV, and VP combined model have significantly better performance than using VP only, because VP traffic need to go to the district, SRV does not in combined model. And the second thing is the impact of the number of VNF. So when you increase the number of VNF from 2 to 4 to 6, it only makes an impact in very small packet size, only 64 and 128 packet size. Meanwhile, in a 256 packet size to above, there is no difference in the performance. Meanwhile, with the multi-node scenario, we observe the size decrease in the performance of the throughput from the packets that is lower than 512. And with packets larger than 1,000 bytes, then there will be no difference inside the performance between multi-node and single node. So in the future work, we want to benchmark and test the performance of different internode network techniques. They are layer 2 underlay, some endpoint-based LAN or BGP, where we connect between the 2 nodes. And we also want to benchmark the eBPF and HTTP isolation model as well, with two options, with or without uploading it into the SmartNIC. And we also update our draft based on the result. So this is our team member, and this is a GitHub link. Thank you for listening.
Okay, so I will talk about what we have done on with SHIC. So SHIC is a protocol to compress IP header to put IP in very constrained networks, such as LoRaWAN, Sigfox, or 5G narrowband IoT. And so we have this RFC that describes SHIC, and we use OpenSHIC to develop the standard, but it has been done by several developers, and now our effort is to put all the things together to have something that works well with all the features together, that is well documented to help people to use it. So that's what we did, and we also work on a young version of the description of the rules to allow interoperability between different implementations. And we also work on a new feature that is called Compound Act that is used, for example, for Sigfox technology. So what we have done, so we implement the platform. We also have some documentation effort to understand what is SCHIC and how to use it with OpenSCHIC. We have so pushed the core conf version of the young model, the young description model into the GitHub, and we have also this version of SCHIC. So what we have learned, so that first core conf is quite nice. So we have a very, very compact representation of the rule. If we compare to the JSON version, we divide by 6 the size of the rule. So that's quite interesting, especially in compressed network. But we have discovered some funny things with core conf, is that you classify all the entries by alphabetical order. And we have, in each rule, we have the rule ID, and the rule ID is 30 value after the reference value. So it means that in CBOR, we need 2 bytes instead of 1 byte. So this is not that bad, but we can try to improve the compression by changing the seed order, and we will have to discuss about that in the working group. And for the members, so we have people that were here, like me. We have Dominique Bartel, Sergio Aguiar, and Cedric Hadj. We were remote. And we have 2 newcomers, that was Ivan and Diego, that are here. And if you are interested by OpenSCHIC, so we will make a demo tomorrow. And you can go to this GitHub to get implementation. Thank you.
So Melissa is trying to present, but it doesn't seem to be working. We'll try again. Nope. Yeah, we've tried a few times. Melissa, if your presentation is one that's been uploaded, I can share it here. Oh, you're right here. Oh, okay. Okay. Anyone else that has a presentation that we didn't get to yet? All right. So while we're getting that one sorted out, let me just go and do this. I have a couple reminders. So after we finish with this presentation, that'll be it for the hackathon. But we do still have Hack Demo Happy Hour, and I'm really happy about this because this is one thing that we didn't even attempt to do in an online only event. But so we'll have Hack Demo Happy Hour for any of you that want to host some deeper discussions about your project. If you want to stick around and you'll have a table and people can come up and you can do demos or talk about your work. And so it's an hour and a half, as you can see here. It's from 1700 to 1830 tomorrow. And you can register now. You can register up until noon tomorrow if you want to participate. And then we'll have some space there. It'll be in this room. I don't know if it's on this side or this side, but you can come, you can set up whatever you want and just have a more in-depth conversation with people. Whether they participate in the hackathon or not, they can come find you and learn more about your project. So if you're interested in doing that, I think it'd be great. Please just make sure you register, and then we'll work with you to get the space up and the logistics and that. Can I just see, is there anyone here who's planning on presenting their project tomorrow at Hack Demo Happy Hour? Great. So, and hopefully we get a few more. Okay, wonderful. And for people who are remote, you can participate as well. We will have, I don't know if we use Meetecho, but we'll talk with you about how we're going to do that. We'll have some type of video conferencing set up for you. The other thing is this room will stay available, so you can come here, and this will be the IETF lounge, but a part of it will be designated as the code lounge. So if you want to continue to work on your projects throughout the week of the IETF, you're welcome to come, and you can register for that as well. You don't have to, but just to help you arrange your schedules with other people, you might find that interesting. So you can advertise basically when you're going to be here and have people meet you here. So that's another thing you can do. Other than that, I just want to once again thank our sponsors and many of you have already said that you plan on attending in Philadelphia. So we will have another hackathon there and hopefully work out some of the kinks, but it should be great. And so I hope to be able to see you there. And if we can, we'll go back and get our last but not least presentation here. So Marco's going to try this time. Yeah, looks good. All right, that's all yours.
Hello, everyone. Sorry for keeping you. So we are the participants at the table H, together with a couple of newcomers, David and Loic, who are very welcome, who have been very welcome to join us for this hackathon. So we are the participants in the Lake working group, where we standardize a lightweight authenticated key exchange protocol for constrained environments, and constrained means embedded systems in most cases. And we have 9 implementations of the Lake protocol that are available. This includes embedded implementations in C, C++, also Java and Python. And as you probably know, the embedded programming language is dominantly C, but C is memory unsafe. So that kind of goes against the saying that protocol is as secure as its implementation in the wild. So our goal is to produce an implementation that is provably secure. And what that means is that we can prove correctness on the implementation, correctness in respect to a given model, to prove memory safety of the implementation, and to prove its side channel resistance against side channel attacks. So it turns out that these folks from the researchers from the INRIA Institute in France have developed a framework that uses Rust to specify a model that is able to generate a formally verified code. So what you see here, I won't go into details. I'll go right quickly because this is the last presentation. This is the methodology. And essentially, in practice, what it turns out to is that you need to implement some code in Rust, in a subset of Rust called HackSpec. And once you get to that, this is your kind of model that later you turn into, that you compile into this language called F star that they use to generate and formally prove properties on the implementation. So this is not output of my research. This is the output of research from the Prosecco team, and namely Kartik Bhargavan from India. So essentially, the first step, as I said, is to implement this model in Rust HackSpec to generate this F-star model, which is automatic through their tools. And then there is a third step to write and verify another mathematically abstracted language called Lowstar against this F-star implementation. And finally, to generate some formally verifiable code, which can be either Rust or C. Again, so you start from Rust, and you end up with Rust or C, which is formally verified. And this is available on GitHub. This is their framework. So our goal for today and yesterday was to write this model of HackSpec of our Lake protocol. So the implementation goals, we want verifiable code, but that can be executed on microcontrollers. We want a minimal implementation, so we're not aiming for something generic. A minimal implementation in our case means static Diffie-Hellman authentication with initiator mode, only in the initiator mode. We don't want any dependencies. So basically what we've done is purely pure Rust without dependency on the standard library. So I'm talking no memory copy, implementing memory copy with for loops. We want to rely on hardware acceleration wherever possible, obviously, and we want this to be portable to other environments as well. So native machines and also other embedded platforms. So before the hackathon, we came here with a partial implementation of ad hoc. Ad hoc is the protocol that is standardized in Lake. With unit functions passing the test vectors that are published in the draft in Lake. We came with a full crypto support for on non-constrained devices with HackSpec, and we came with hardware abstraction layers for two platforms, CC2538 and NRF52840. So this was our starting point. What we got to implement is that we extended the API, we implemented the API, we implemented the protocol state machine with HackSpec. So it's important to understand, I mean, I was talking about formally provable code. So this model that you write in Rust, this is executable code. This is an implementation just as any other that can interoperate. And we proved that during the hackathon. We interoperate with Californium, with Java-based implementation, Californium ad hoc. And yes, here you can see some screenshots from the implementation, essentially the protocol deriving the same shared secret after the run of static Diffie-Hellman authentication. And yes, the code is open source under BSD license, available on GitHub under this link. Next steps for us to complete this port. So this was working on the native. We didn't kind of get it to work on the embedded side yet. So these will be our next steps on CC2538 and NRF52840. And obviously to publish this as a crate on crates.io. And once we get done, this will wrap up the model. So essentially what we want to use as the model. And then we want to go ahead and generate formally verified Rust and C code that can be executed in microcontrollers. So that would be it. Thank you. Are there any questions? I hear none.
Okay. I think that's it. Any other presentations? We got them all? All right. Well, fantastic. Hey, thanks everyone for participating in the hackathon. It's super exciting to have the opportunity to be here in person again. And thanks for sticking around for all the presentations. I do hope to see you tomorrow. I want to say a big thanks to Barry too, who many of you didn't realize he was doing a lot of work in the background, whether it was getting you signed up for GitHub or converting your your presentation. So he really helped things go as smoothly as, or not be even rougher than they already were. So a lot of, when you see Barry, is Barry back there anymore? But you'll have to give a big thanks to Barry for all the work he did, and he really helped me out a ton. So, and again, thanks to all of you for being here, and have a great IETF. You're welcome.
That's actually a great idea. With the mask, with the otherwise. Closer. I think
you want us around. You want to look like we're speaking.
Yeah, no, like. Or can you get a sound on it? I think you should. Do you also have this printer there? Perfect.
Okay. Yeah. Oh wow, that camera's like you see a lot more than I would have guessed. I guess wide angle.